Bismillahirrahmanirrahim. Assalamualaikum and very good morning or good afternoon to everyone. Here I am Ridhwan Jumaidin from Universiti Teknikal Malaysia, Melaka. And today I'm going to present my paper entitled Water Transport Properties of Thermoplastic Cassava Starch Beeswax reinforced with Cogon grass fiber. Okay, as the presentation outline, I'm going to present the introduction, Biobased Polymer, Thermoplastic starch, and then the modification of thermoplastic starch by using Cogon grass, the results, and the conclusion. Here's the introduction. This is the problem that we face nowadays, where most of the material used is plastics from synthetic polymer. Okay, and these materials are not degradable and non-renewable, and it has created a serious environmental problems upon disposal, as you can see in this picture. So every year around 500 billion plastic bags were used, and as much as 1 million plastic bags are being disposed for every minute. Then these plastic bags are difficult to dispose in the environment. Here, for example, the ocean, lake, where it takes around 300 years to photodegrade. So this, you can see, this is the problem happen where the turtles, it tends to confuse the plastic bags with the jellyfish. So when it degrades in water, it will pollute the water. So it's not only to the animals, but also convey difficult issues to the human being and the environment as well. So here comes one of the solutions. We call it the bio-based polymer. So biopolymer is materials made from natural resources. Seems to be a promising approach for this global issue. It is readily biodegradable, and that is more environmental friendly than the conventional polymers. So among all the biodegradable polymers, starch has been reported as one of the most promising one because it's easily available, it's biodegradable, it's also renewable. So starch, it can exhibit special things about these materials. It can exhibit thermoplastic behavior with the addition of plasticizer, heat, and also shear. So to develop plastic from starch, the granular structure of starch must be either totally or halfway destroyed under high temperature and shear with the presence of plasticizers such as glycerol, sorbitol, water, and others. So this is the SEM image of the starch granules. It's like a spherical or image, like something like that. So this is how we develop the thermoplastic starch. Basically, the materials were mixed by using starch and the glycerols, okay, and then we press it in the hot press, and then it become like a very clear plastics. We call it a thermoplastic starch material. So thermoplastic starch, it can act as a plastics, it's present of heat and high. However, the strength is extremely poor because the blending of starch with the materials is necessary to improve the strength and the stability of the material. So natural fiber is one of the solutions because it can be improved the properties of materials or polymers, synthetic polymers, where it acts as a reinforcement agent for the plastics. So here we want to use the natural fiber to improve the properties of thermoplastic starch. So here we have prior modifications for our studies using Beeswax. It's some sort of wax because thermoplastic starch is known for the weakness on poor water resistance. Okay, so this is how we want to apply Beeswax, okay, so that it can improve the mechanical and moisture barrier and also reduce the water solubility of the thermoplastic starch. So this work has been published earlier. So we are using this material blend as our polymer matrix. Instead of using thermoplastic cassava starch, we are using the one that we have developed earlier, which is thermoplastic cassava starch Beeswax as the materials. Okay, so here we're using the earlier mentioned material, the PS Beeswax, and then we mix with fibers. We want to explore what is the potential of the Cogon grass fiber for this material, because we know that Cogon grass is normally just being discarded as a waste as a problem for plantation. So here we want to utilize the Cogon grass, so to see what is the potential. So for the modification, we are using different types of fiber loading, which is 0 to 40% of fiber loading by weight percent into the thermoplastic starch Beeswax. So we conducted 3 types of tests for this paper presented today, even though we also did another type of testing. But for today, we are presenting these 3 types of testing, which is a moisture content analysis, water absorption, and also for thickness swelling. Okay, so for the moisture content, as you see in the figure here, the moisture content was tend to show a reducing trend, as the amount of fiber will increase from 0 to 40%. So the decrease in moisture content of the composites might be attributed to better interfacial bonding between matrix and the fiber, as the resistance to absorb the moisture. And then this can also be associated with less hydrophilic character of Cogon grass fiber within the TPCS Beeswax matrix. So this finding also is in agreement with Mali and Lebegi et al., which reported that the use of natural fibers and biodegradable polymers in material production is to increase resistance to moisture. Also, and then we go for the water absorption results. As you can see, there's a 2 line here. So what happened is that we conducted the test for 0.55 hours and for 2 hours. Beyond that durations, what happened is actually the material started to disintegrate, which shows that this is completely biodegradable in water. Okay, so it's apparent that water octave bond material decreases with longer immersion time. Okay, as you can see here, for 0.5 hours, it's only about 60%, and after 2 hours, it's about 120%. Okay, so in general, it can be seen that the incorporation of Cogon grass fiber with Beeswax decreased the water absorption. So you can see here the trending is reducing. Okay, so according to the Provice et al., natural fiber not only decreases the tendency of thermoplastic to absorb water, but it also makes the composite almost insensitive to water absorption. So it's reflective of the amount of glycerol and the fiber. So in terms of the thickness swelling, thickness swelling is the test conducted to determine the specimen dimensional stability, especially when it's in contact with water. So from this figure here, it is clear that the emission time and the fiber loss influence the thickness of matrix and the composites. Okay, so the thickness swelling percentage of about for the 0.5 and 2 hours is about 38 and 41%. Okay, but for the composites, the percentage become 37 and also 87%. Okay, for 2 hours. So as you can see here, what the trend is slightly different with the water absorption. Okay, where the sample with fiber showed the higher swelling. Okay, as compared to the matrix. Okay, so this sample, okay, for 30% 40% fiber was disintegrated, okay, and eliminated during the test. So it's also difficult to take the testing results of the samples because when it disintegrates, the thickness cannot be measured accurately. Okay, but somehow, anyhow, this shows that this material is environmentally friendly for sure. Okay, so as the conclusion, incorporation of TPCS Beeswax with Cogon grass fiber was successfully developed using Cassava starch Beeswax, glycerol as the plasticizer, and Cogon grass fiber as a reinforcement for 10 and 40% by using dry mixing and hot press. So the moisture content of absorption shows a similar trend, where the fiber loading is increased, okay, and then it's resulted to decrease its properties. Okay, for the thickness swelling, the results was affected to this moment by the elimination and the disintegration of the specimens. So this is what happened during the study. And overall, this study shows that the Cogon grass is able to reduce the water affinity characteristics of the TPCS, hence providing potential application of the material as a new biodegradable alternative. Okay, so the acknowledgement, the authors would like to express sincere gratitude to Universiti Teknikal Malaysia Melaka and Ministry of Higher Education Malaysia for the financial support provided through research grant as 2019, TKMP KF00413, and the conference was supported by the Publication Intensive Grants Journal FTK 2018 Q0004. Okay, so we would like to share also we have developed a biodegradable Cogon grass strain. Okay, by using the mixture of TPCS and Cogon grass. Okay, so that's all from me. Thank you.